Howdy. We are at the end of the end for Chapter 6. So this is the closeout, el finale, before we get into our review and ready for our exam on this. Today is going to be Chapter 7.6, Part 2. We looked at solving exponential equations yesterday. Today we're going to be looking at solving logarithmic equations. Yesterday, when we solved exponential equations, we introduced a log to both sides of the equation in order to solve it. Today, we will have logs on both sides of the equation, and whatever will we do to get rid of a log? Yes, that's right. We will introduce a base to both sides of the equation in order to get rid of our logs. It's almost as if exponents and logs are inverses. It's almost as if exponents and logs undo each other. It's almost as if when we have range restrictions for exponents, we have domain restrictions for logs. It's almost as if when we have horizontal asymptotes for exponents, we have vertical asymptotes for logs. It's almost as if they undo each other. It's almost as if they're connected. It's almost as if we're talking about the same thing. Oh me, oh my. Here's what it looks like. Match the bases up, log both sides, and solve. So isolate the log, just like yesterday. I'll write it down for you. Isolate the log. Introduce a base. And solve. We're going to do one example where we may get an extraneous solution. Remember, an extraneous solution is an extra solution. You do have, when you have two answers, they both might work, or one will work, one won't, or they both might not work. All right, here's what it's going to look like. Example number 1, log base 7 of 6x minus 16 equal to log base 7 of x minus 1. We have a log 7 and a log 7. I sure would like to get rid of the log 7 and the log 7. However, will I do that? I don't know. Introduce a base 7 to both sides of the equation so that when I do that, I've isolated the log. There's my identity. I have 6x minus 16 equal to, there's my identity, x minus 1. Solve the equation for x. This is Algebra 1. I almost made a mistake right there as I was talking about Algebra 1. That would have been embarrassing. 6x minus x is 5x. Negative 16 plus 16 is 0. Negative x minus x is 0. Negative 1 plus 16 is 15. 5x equals 15. Divide both sides by 5. And x equals 3. That's all there is to it. Match up your bases, get rid of your logs, and solve. Name of the game, matching things up. Next example. Log of 3x equals a log of x minus 8. Once again, the log of 3x equals a log of x minus 8.
But Mr. Wood, there's no base on both sides. I don't know what to introduce to get rid of my logs.
What? What's that? You don't have a base to introduce to get rid of your logs? There is no base that's indicated here on this log of 3x. That must mean it's a common log, a log base 10. If it's a log base 10, then I will introduce a
Base 10.
Yeah, that's right. I'll introduce a base 10 to both sides of the equation. When I do that, there's my identity, and I have 3x. When I do that, there's my identity, and I have x minus 8. Solve the equation for x, and you're done. Divide both sides by 2, and x equals negative 4. Oops, sorry, didn't mean to scroll there. There you go. That's it. And if you were good with yesterday's stuff, you're going to be good with today's stuff. Next example. Log base 5 of 3x minus 8 is equal to 2. That's a problem that looks hard. It's not. Again, log base 5 of 3x minus 8 is equal to 2. This problem sure would be a lot better if I didn't have a log base 5 in it. Sure would like to get rid of that log base 5. However in the world will I get rid of the log base 5? Perhaps I'll introduce a base 5 to both sides of the equation. When I introduce a base 5 to both sides of the equation, I have an identity there, and my left-hand side simplifies to 3x minus 8. On the right-hand side, my answer simplifies to 10. Right? I hope you're one of the students that right now is going, that should not be 10, Mr. Wood. That answer is 25, not 10. Most common mistake on this problem. 5 times 2 is 10. That is correct. However, we did not multiply both sides of this equation by 5. We introduced a base 5 to both sides of the equation. By introducing a base 5 to both sides of the equation, that answer is not 5 times 2, but is actually 5 squared, which is 25. Now solve for x. 3x equals 25 plus 8. That's 33. Divide both sides by 3. And x equals 11. Mr. Wood, this is the easiest stuff we've done all chapter. Yeah, it probably is. But I want to make sure that you understand what's happening in the problem. And I think because we've spent so much time talking about this, i.e. the last 5 or 6 days, that's why this problem's easy. If I'd have just started with this, I don't know how much sense it would have made. All right, we got a checkpoint coming up for you guys. Pause the video, do the checkpoint, and unpause when you're ready to move on. Log base 3 of 2x plus 9 equals 3. All right, hopefully you finished that problem. I expect that you finished that problem, and we're moving on to the next example. Whew. That looks hard, Mr. Wood. 5 log 4 of 10x plus 624 equals 25. Those are some big numbers. I thought you said we weren't allowed to use a calculator on this test. Well, it's not going to be too bad. We've got to get the log by itself. I do need to get rid of the log, but I sure would like to get rid of that 5. That says 5 times the log base 4 of 10x plus 624 equals 25. 5 times that log, I think I'll divide both sides by 5. I think that's a great idea. That gives me log base 4 of 10x plus 624 equals 25 divided by 5, which is 5. I would like to get rid of my log 4, my log base 4 at this point. The way that I will get rid of the log base 4 is introduce a base 4 to both sides of the equation. 4 to the log 4, there's my identity. That gives me 10x plus 624 equals 4 to the 5th. 4 to the 5th, I don't know that off the top of my head. That is 4 times 4 times 4 times 4. That's a pretty big number. I would let you go ahead and use a calc for this. So we're looking at 4 to the 5th. 4 raised to the 5th. 1,024. So 10x plus 624 equals 1,024. We're going to go ahead and minus 624 from both sides of this equation. That gives me 10x equals 400. Divide both sides by 10. And x is going to equal 40. Done. That's the nuts and bolts of it. Get those logs by themselves, get rid of the logs by introducing a base, solve for x. Very similar to what we did yesterday. In fact, it's the inverse of what we did yesterday. Your guys' checkpoint, pause the video, make sure you can solve it. After that, and I'll tell you, you don't need a calculator for this, so try to solve it by hand. Log base 2 of x minus 6 equals 5. Unpause it when you're ready to move forward. Okay. Believe it or not, we are already on our last example of the day. Now, we'll tell you this is the longest example. There is some things that need to happen here. So if you thought the rest of it's easy, everything we've done up to this point, it's easy, that's good. It is easy. This problem's a little bit more involved. It's not too bad, but I do want to show you some things, okay? First off, we've got log of 5x plus a log of x minus 1 equal to 2. What we need to do is use what we did 2 days ago. Mr. Wood, I barely remember what we did yesterday. What did we do 2 days ago that was so important? The thing that we did 2 days ago that was so important is that we expanded and condensed exponential and logarithmic equations. Again, we expanded and condensed exponential and logarithmic equations. The reason we did it is so that when we get to today's problem, I can solve it. I have log of 5x plus the log of x minus 1. The addition tells me that I have multiplication here. So my first step when I have an expression like this is to rewrite it. And my rewrite will say this: log of 5x times x minus 1 equals 2. Remember, when I condense it down, I go from the 2 logs to 1 separate log. And the reason I have to do this is because I now need to introduce the base to both sides of this equation. And the base that I introduce to both sides is the base 10, because once again, that's my common log. And that's going to be my identity. 10 log 10 is my identity. I have 5x now times x minus 1 equal to. No, that answer is not 20. That's 10 squared. 10 to the second power, we introduce the base. That's 100. Now, I'm going to take a little bit of time, and I will backwards map what happened there. That's the hardest part of really today. My original expression was log of 5x plus the log of parentheses x minus 1. The other day, we talked about how addition means multiplication. So I need to rewrite first before I introduce my base. So rewrite, then introduce base. The problem won't work if you don't rewrite it first for these. All right. From here, we have 5x times x minus 1 equals 100. How do we solve that? Well, I'm glad you asked. The first thing we do is we distribute the 5x to the x minus 1. That gives me 5x squared minus 5x equal to 100. Oh, no. I see what you did, Mr. Wood. You tricked me. I know how to solve this problem. I just don't like it. Minus 100 from both sides of this equation, and we have 5x squared minus 5x minus 100. Some of you guys are going, sweet, we're back to factoring. I know how to do this. Let's see. 5x squared minus 5x minus 100. Hopefully, you're going to make your job easier right now by realizing there's a common factor of 5 that you are going to divide out on all sides of every part of this equation so that it simplifies to x squared minus x minus 20 equal to 0. Whew, that's not so bad. I can do this. Negative 20, negative 1, x over. Let's see, that's going to be a negative 5 and a positive 4. So we've got x minus 5 times x plus 4 equals 0. X equals 5, and x equals negative 4. Sweet, I'm done with the problem. No, you're not done with the problem. We've got to check for extraneous solutions. Some of you guys are probably saying I went too fast in that last part. So there you are. There is the word for the last part. It is just factoring, which is why I went fast. But now we need to look at the original problem to see which of these two. They both can be solutions. They both may not be solutions, or one of them might be a solution and the other one might not be a solution. So we've got to check them both, and we always have to check in the original problem. So I'm going to do the 5 first. That's going to say the log of 5 times 5 plus the log of 5 minus 1 equal to, what was that? 2. So that's a log of 25 plus the log of 4. Oops. Equal to 2. You'd have to use your calc for that. So we're going to go the log of 25 plus, the log of 25 plus the log of 4. It's 2. So the log of 25 plus the log of 4 simplifies to 2. Then that solution checks. It has to work in the original in order to be a solution. So I like 5 as an answer. I'm now going to check my negative 4. So that says the log of 5 times negative 4 plus the log of, wait a minute, did I do something wrong here? Oh, we're good. Log of negative 4 minus 1 equal to 2. So that says the log of negative 20 plus the log of negative 5 equal to 2. The log of negative 20 plus the log of negative 5. Uh-oh. It just said I have an error. I have a non-real answer. What do you mean I have a non-real answer? I just got an answer. I got x equals negative 4. Yes, you did get the answer of x equals negative 4. And that is a possible solution. However, when we graphed our logs, we had a domain restriction. We had a vertical asymptote at x equals 0. And I told you when we had those things, x can never be less than 0. In other words, in reality, I can never take the log of a negative number. And since I'm taking the log of a negative number, that's impossible for me to do. That'd be working on the other side of that vertical asymptote. It doesn't exist. We can't do it. So this is an extraneous solution. It's a non-real answer because it doesn't exist. We can't log any negatives. In fact, try logging anything you'd like a negative. Take the log of any negative. Log of negative 5. Non-real answer. Log of negative a million. It won't work. We have the domain restrictions because we can't log negative numbers. And I'll clarify right now. That doesn't mean the positive answer will always be your solution and the negative answer won't be your solution. In fact, I challenge you to come up with a problem that the negative might be an answer and the positive won't work. Okay? Because that's the case. So you got to check both your answers and make sure they work on these type of problems. Besides that, that's just kind of the fine-tuning part. For those of you guys who are going to honors pre-calc, make sure you kind of understand that idea of how the domain restriction matches those extraneous solutions. For those of you guys hitting at Algebra 2 or going on to regular pre-calc, my expectation is that you can plug it in and tell me which one of those is the answer and which one isn't. Okay? That is as hard as it's going to get today. Again, it's just one extension step from all the rest of the stuff that we have done. And I will also tell you today's password is enjoy your weekend. Let's make it hope you enjoyed your weekend, because we'll be coming back and checking on these on Monday. So password is hope you enjoy the weekend. You guys do have one more checkpoint left to do. This is the end of the video, so I will sign off. You can pause it on this last page, and then you are done. See you guys back in class on Monday, and hope you enjoy your weekend.